Today we're going to continue with Chapter 1 in Geometry. We're looking at Section 1.2. So today we are going to be classifying angles by size, and then we are going to recognize congruent angles and segments. So once again, we are going to continue by looking at more vocabulary, looking at any specific notation that goes along with that vocabulary, as well as then doing some practice problems. So these vocab words are just as important as the very first lesson where we are starting to get the foundation of geometry, which once again, remember, is just like a language. And so it's very important that we know these vocabulary words. So an acute angle. It is an angle whose measure is between 0 degrees and 90 degrees. Okay, I'm sure you guys have heard about acute angles in the past. Now, pictures are going to have angles that look pretty small. So we can never really assume what the size of an angle is, and that's something that we'll talk more about in the future. But angles that are small looking, like this picture right here, this would indicate an angle that is in between the measure of 0 and 90 degrees. Now, there's no specific notation for us to identify an acute angle, so I'm going to leave that last box blank. We have obtuse angle. An obtuse angle is an angle whose measure is between 90 degrees and 180 degrees. Okay, so this angle is definitely much bigger. So something that looks like this. This is a very big looking angle. I'm going to call this angle DEF. Okay, much bigger than 90, smaller than 180, but some measure in between. This would represent an obtuse angle. Once again, there is no specific notation for an obtuse angle, so I'm going to leave that last box blank. A straight angle is an angle who measures 180 degrees. Okay, so it's exactly that measure. And so anytime we see an angle that's 180 degrees, we would say that it is a straight angle. So notice that my picture right here looks an awful lot like a line. All right, and that's what a straight angle is as well. Notice that you have to have 3 points on this picture that looks like a line in order for us to classify it as an angle. Notice that in the middle, H is that point. That would be considered the vertex of this angle. So I would call this angle GHI or angle IHG. Okay, so you have to have 3 points in order to consider it a straight angle. If there's just 2 points, then I would just call it a line. But it has to be nice and straight. It measures 180 degrees. Once again, no specific notation for a straight angle. A right angle is an angle whose measure is 90 degrees. So exactly that. So 90-degree angles look something like this. Okay, if I call this J, K, and L, this would be a 90-degree angle. And so there is a specific notation for us to identify a right angle. When we have something that looks like this, to know it is absolutely a right angle, if it's not told to us, you would have to have this box inside. So this box indicates a 90-degree angle. Okay, so I'm going to go back to this picture. I have to have a box inside. If I was not told that it's a right angle, I need that box to know that it is indeed a 90-degree angle. Congruent. Congruent angles are angles that share the same measure. So congruent, we can think of a lot like the word equal. Equal, something that we've been talking about since the beginning of math. When we were taking and solving an equation, we put two things equal to each other. So congruent is very similar to that. So angles that share the same measure, we say we have congruent angles. So a picture would be if I have this angle, let me call this angle MNO, And then I have a second angle. I'm going to call this angle PQR. So say I have these two angles. In order for me to know that these are in fact congruent, that they have the same measure, we would have to have been told that they're the same measure. Like we'd have to be told angle MNO is 50 degrees and angle PQR is 50 degrees. Okay, we do have a notation. So here I'm going to write my angle MNO. N's in the middle because that's the vertex. This is the symbol for congruent. Notice that there is an equal sign and there's this little tilde above it. So this symbol right here represents the word congruent. Okay, so that word right there, or that symbol, represents the word congruent. Okay, so anytime we see that, we can think equal. So if I see this, PQR, so angle MNO, then that symbol for congruent, and angle PQR. So there's my notation to indicate that they are indeed the same measure. Another way for me to look at it, if I didn't have that notation, if I look at my picture and I see something like this, if there's this specific mark inside at the vertex of N, if I have that exact same marking inside the vertex of Q, same marks represent congruence. So when there are marks inside the vertex and they are the same, then we know that the angles are congruent. Okay, so because they both have that little mark inside with that line going through that mark, that means that they have the same mark, and so those angles are the same measure. Congruent segments are segments that share the same length. So say I have this segment, I'm going to call it ST, and then say I have this segment, I'm going to call it segment UV. Okay, if I specifically write segment ST is congruent to the segment UV. So if I see that notation there, that tells me that they are the same length. So they go from the same distance from one point to the same distance on the other. Okay, or once again, I could have specifically given you a length. I could have said that ST, that segment was 2 inches. Well, then that means that the segment UV has to be 2 inches in order for them to be congruent. Or if I have some marks that are the same. So notice I put 2 little tick marks inside of both of those segments. So the same tick marks represent congruence. Okay, there's a lot of different ways you can do tick marks. Here I put 2 little ticks inside. I could have done 1. I could have made it look like a V. I could have made it look like a circle. So I'll kind of show you a bunch of different tick marks throughout the way. But these little marks inside the segment, as long as they are the same, that also indicates us in this picture that they are congruent or the same length. So we're going to look at these 2 diagrams below. We are going to name the congruent segments and the congruent angles. Okay, so let's start with the segments. And remember, we just talked about segments. As long as they have the same marks, because in this case, I don't see any numbers, so I don't know based off of specific lengths if anything's the same. So I have to look for marks, those tick marks. Okay, so notice that on the far left, I see a diagram where the segment AB has 1 tick mark. I don't see any other 1 tick mark on that diagram on the left, but if I move over to the diagram on the right, I see a 1 tick mark in 2 other spots. So that tells us that the segment AB is congruent to the segment SO, because notice between S and O, I see one tick mark. And then also between O and P, I see one tick mark as well. So that tells us that that's also congruent. And once again, notice how with my notation, there are no arrows when I'm talking about segments. So all of those have one tick mark. So that indicates that those three are the same length. But notice that I also see other marks on segments. Down at the far bottom left, I see that DC has 2 tick marks. Notice that I don't see any other 2 tick marks on the left diagram, but on the right diagram up at the top at RS, I also see 2 tick marks. So that tells me that the segment DC is congruent to the segment RS. Notice that I wrote that separately from the 3 at the top because I don't want to keep stringing all of them together, because then that would tell me that all 5 of these are congruent, and I don't know that. I don't know that RS is the same as SO because they're marked differently. If a segment is not marked at all, we do not indicate that as being congruent. So because RO doesn't have any markings and neither does OQ, I cannot say that those two are the same length. So they have to have some kind of marks to indicate that they are congruent. And that looks like the only types of marks that I see on segments. So I'm done with naming congruent segments. So now I can move on to angles. And if I'm looking for angles, I'm looking for, because I don't see any numbers, I'm looking for marks inside of the vertex that would be the same. And notice on the far left, I see angle E. And notice that there is only one angle E. I don't see multiple angles at that particular vertex. It has 2 little marks inside. And notice that in the same diagram over by point B, I see 2 marks inside there. So I can say that angle E is congruent to angle B. Once again, both of those angles only have one angle at that particular vertex, which is why I was able to name it with one letter. Okay, I don't see any of the same markings on the diagram on the far right. So that is one set of congruent angles. If I look then, I see that I have at the very top of the far left at A, I see one particular marking. And notice that I see the same thing over on the diagram on the right. But if I'm looking at A, there are a lot of different angle A's. And so this time I have to actually use 3 letters. And A has to be in the middle because that is the vertex. So I'm going to say angle. Now I'm going to highlight this so you can see it a little bit better. But notice that it's this right here that has that one mark. And so that has nothing to do with the letters of E or D. It has everything to do with the letters of A, B, and C. But A has to go in the middle because that's the vertex. So I'm going to say it's angle CAB. And then if I look over on the diagram on the far right, I see the same marking by the letter O. And I see it not once, but I see it twice. So notice that here, this angle has that. And so because there's actually more than one angle O, I have to use 3 letters. I'm going to say angle ROS, because once again, O has to be in the middle. And that's going to be congruent to, one more time, we've got this angle down here that has that one same marking again. And so I have to use 3 letters, but O has to be in the middle. And I'm going to call that angle POQ. And that looks like the only angles that are marked. So because some angles are not marked doesn't mean that they're congruent to the other angles that are not marked. So then that means that I'm done. In the next example, it wants us to find the value of x. And so after we find that measure, we're going to find the measure of both angles. So we find x, and then we find the measure of both angles. Notice that in this particular picture, I have the same marks inside the vertex. And when they are marked the same, that tells me that they are congruent. And once again, congruent means equals. So to find x, 5x plus 7, which is the first vertex here, is going to have to equal the vertex over here, which is 3x plus 23. And so if I start solving this, I'm going to combine like terms. So I'm going to move that 3x over by subtracting. That now gives me 2x plus 7 equals 23. Got to get the numbers away from the x, so I'm going to move the 7 over first by subtracting. That gives me 2x now by itself. 23 minus 7 is going to give us 16. And then finally, to get x by itself, I'm going to divide by 2. So the first half of my answer, because it says find the value of x, 16 divided by 2 is 8. So x equals 8. And now because these two angles are congruent, I'm going to take that measure of 8 and I'm going to substitute it back in to actually either one of those expressions. I'm just going to go back to the angle ABC because I know that they're the same. And so I know that angle, the measure, that little m in front tells me that's what I'm talking about. The measure of angle ABC is going to equal 5 times 8 plus 7. Well, 5 times 8 is 40. 40 plus 7 is 47. So it's a 47-degree angle. And same thing, if I was to wanting to find the measure of angle XYZ, I could take 8 and I could substitute it back in. And so we've got 3 times 8 plus 23. Well, notice that 3 times 8 is 24. 24 plus 23 is going to once again get us 47. So you don't really have to do that extra work, but I wanted to show you that when they're congruent, that means that the measure of both those angles have to be the same. They're equal. All right, so notice that in this example, it says given. So anything that's given to us is going to help us then set up a problem in order to solve for what they're asking for us to find. So it says we are given that angle ABC is a right angle. Remember, from our definition, a right angle means that we have a 90-degree angle. And so if I follow the letters ABC, I'm going to mark that in my picture. Remember, that little box indicates that we have a 90-degree angle. It says that angle 1 is represented as 3x plus 4. I like to write that information inside the diagram. It helps me visualize. So by that little 1 that represents angle 1, I'm going to put that expression 3x plus 4. We are also given that angle 2, which is this little angle down here, is x plus 6. We want to find the measure of angle 1. Now, notice that nowhere in this given information did it ever say or show the symbol for congruent. And so because nothing is congruent in this, I'm not setting those two expressions equal to each other. But those two small angles form that 90-degree right angle. So the only option here I have in order to start solving for x is to add those two little angles together and set it equal to the measure that I know it is, which is 90 degrees. So I can start combining like terms. 3x and x are on the same side, so that turns into 4x. 4 plus 6 is 10. That still equals 90. Start solving for x. I'm going to subtract 10. So now 4x equals 80. I'm going to divide by 4. And x equals 20. Now, I'm not going to circle that. That's not my answer. It's asking for us to find the measure of angle 1. X equaling 20 is not the measure of angle 1. Remember, angle 1 is 3x plus 4. So the measure of angle 1 is me taking 3 times 20 and adding 4 onto it. 3 times 20 is 60. 60 plus 4 tells me that I have a 64-degree angle for the measure of angle 1. This next one tells us that we are given that angle B is an acute angle. So remember, our definition of what it means to be acute is that it's going to have to be a measure that's between 0 and 90 degrees. And so when it's asking what are the restrictions, that's exactly it. So 0 degrees is the smallest that it can be. It's not going to be equal to it either. There's no such thing as a 0-degree measure. So then that's going to be less than the angle B that we're talking about, but then angle B has to be less than 90 degrees. It can't equal 90 because then that would make it a right angle. It has to be smaller than 90 but bigger than 0. So there is my restriction. Angle B is in between 0 and 90 degrees. So then if it's asking what are the restrictions on X, well, notice that angle B is given to us as 2x plus 14. I'm going to substitute that into the restrictions above. So 0 is less than 2x plus 14, which is less than 90. And now I have this inequality that you guys have learned how to do in algebra. And now I'm going to start solving for X to see exactly what those restrictions are. So when I'm thinking about solving a compound inequality, I think about it as two different inequalities. I think about it as 0 is less than 2x plus 14. And I think about it as 2x plus 14 is less than 90. And now I'm going to start solving for X. So on the far left, I have to subtract 14. 0 minus 14 is negative 14. That's still less than 2x. Going to divide both sides by 2. When I divide by a positive number, that is going to keep the inequality sign as it is. So negative 7 is less than x. If I look at the other inequality, I'm going to have to do the exact same steps to start solving for x. I'm going to have to subtract the 14. 90 minus 14 is going to give me 76. And then I'm going to divide by 2. And that tells me that x is less than 76 divided by 2 is 38. So if negative 7 is less than x, but x is less than 38, I can put that back together as negative 7 is less than x, which is less than 38. That's my restrictions on x, which means that if I was to actually plug negative 7 into that expression for 2x plus 14, I am not going to get a measure for an acute angle. If I pick 38 or anything bigger than 38 back into that expression, I'm not going to get an acute angle. So anything in between those numbers is going to give us an acute angle for angle B. Here's another error analysis problem. It says Frank is unsure of his answer to one problem from a recent assignment. If you agree with Frank's work on the problem, explain how you know his solution is correct. If you disagree with Frank, then we're going to identify the mistake and solve the problem correctly. Notice that we are given that ABC is a right angle, and then we're given different expressions for angle ABD and angle DBC. So if it helps, I might actually start marking up the picture. So notice that right angle means that I have a box, okay? Notice that B is in the middle, so that's why B is the vertex of that angle, okay? Same thing here, B and B. So I know that ABD is up here, 3x plus 7. DBC is down here, that is 4x minus 1. Notice that we were trying to find the measure of the angle ABD. Looking at Frank's work, he set those two angles inside equal to each other. So the question is, were we told that those two angles were congruent? Are we told that they are equal? And hopefully you're looking at this video and you're shaking your head, no. So I disagree with Frank. So Frank is incorrect. Okay, we do not know that those angles are congruent. Okay, it was not given to us in the given information, and so we can't just assume that. So we can't set those two equal. So instead, hopefully you're like, hey, didn't we do a problem very similar to this already? And we did. Instead, because we were given that we have a right angle, we're going to have to think about 90 degrees. And so I can take those two smaller angles because now it says solve the problem correctly. I'm going to take 3x plus 7 plus 4x minus 1, and I'm going to set it equal to 90 because together those two things add up to 90. So then when I start combining like terms, 3x and 4x is 7x, And then 7 minus 1 is a positive 6. I'm going to subtract 6. That gives me 7x now is going to equal 84. I'm going to divide both sides by 7, and I get the value of x to be, 12. But once again, that's still not my final answer. I want the angle ABD. So the measure of angle ABD is us plugging 12 back into that expression. ABD represents 3x plus 7. So 3 times 12 plus 7 is going to help us get that answer. Well, 3 times 12 is going to get us 36. 36 plus 7 tells us that we have a 43-degree angle. And that is the correct answer. Okay, so that's us classifying angles by size and starting to recognize congruent angles and segments.